Hi, everybody. Thank you very much for coming again. So as Dr. Lang explained, CyberWater has connection to multiple data sources as data agents and multiple hydrological models. And in the future, we also want to include different types of models as like environmental models and biological models and meteorological models, atmospheric models. But right now we do have the VIC and the DHSVM models, which are hydrological models. And I just want to show this is the e-lighting poster that we show in the previous fall meeting for the AGU, which is the American Geophysical Union Conference. I'm very happy with the stuff that we show. Just very concise, and I don't want to spend too much time here showing the kind of information that you guys can access through CyberWater. So the first data agent that I'm showing here is the USGS. So with the USGS, yeah, you guys have access to all the USGS, which is the United States Geological Survey data provider. You guys have access to all these 18,000 different stations and all the variables that these stations measure. So we do need to have some awareness of what is the time frame that is available to each one of the stations, and also which variables each one of the stations have, because not all the stations have all the variables. But in general, this is the information that is available through the USGS. And this one I like a lot because it's really, really fast when you guys use it. The second one that I'm showing here is the NLDAS, which is this is a data source from NASA. And this is a model that it's only cover the United States, which is this is exactly all the information that you guys can get, like all this space. And this one is really nice because you guys can capture a phenomenon that occurs on the hourly basis. So this example is an example of Hurricane Katrina, and you guys can see that you can appreciate the how the precipitation moves inland. But this is only achievable because we're accessing hourly information. The second one, the third one that I'm showing here is the NCA LDAS, which is it covers the same space as NLDAS, but this one is for only daily information. So it's easier to work with like longer time series or longer time frames of simulations using NCA LDAS because it's daily. And the last one that I'm showing here is the GPM data agent. So this is satellite information, also from NASA. The GPM is actually a satellite which is called the Global Precipitation Model, and what we're seeing here is the precipitation in the entire world that we downloaded using the GPM. Like all these images that we're seeing here are images that you guys can obtain through the use of CyberWater tools. So moving forward, this is an example of the VIC model. So this is actually exactly 3.1 in the manual that we're going to check this week. And the information of the French Creek, which is a kind of like a medium-sized watershed in PA. And these are the results. They're exactly the same results that you guys can see in the manual. So what we're doing here is we're running a hydrological model, which is the variable infiltration capacity model, using this is the workflow that you guys would have to build. And we're comparing it with the NCA LDAS model data, just to check how good or better, like we're capturing the same phenomena that they're occurring in the basin, sorry. And these are the results for the runoff, which is the surface runoff. And these are the results for the base flow. We have to say that these results are obtained without any calibration. So what the model is doing, he's generating values for the parameters as default, like within the range, like expected range. And so there's actually like no calibration. So that's why the results are off. But in general, we're capturing the phenomenon, which is what we hope you guys expect. Like this is the expectations are something like this. Moving forward, this is the routing. So in the top one is just the VIC. Here, after the VIC, we're sending that base flow and roundup information to a routing model, which in this case, it works with the Muskingum approach and the Muskingum method. And we're generating stream flow. And we can't compare this information with USGS discharge measurements. In the same case as before, there's no calibration here. We're using default values for the Muskingum method. But we can see we're capturing the kind of like the patterns of the measurements. And finally, the DHSVM model, which is a high resolution. So this is why we're using a smaller watershed for this case. This guy requires more data sources to work. So that's why there's many more boxes before the DHSVM agent. And the information here, we have made changes on the DHSVM, how the DHSVM create the parameters. So the time series that you guys are going to obtain is going to be slightly different. This one right now is much better. It fits better to the measurements. But in this case, DHSVM creates the stream flow directly. So it has both inside. It has the computation of the fluxes and also the routing, the routing scheme. And at the end, I just want to show the generic tools. So this is an example of the generic tools. And to make everything clear, I boxed what is the forcing, which this is how we obtain the data that is being fed to the models. These are the generic tools used as big agent. And these are the generic tools used as the routing model. So the idea is that we can use the generic tools, which are these 4 modules, and they can run any model that we want. In this case, we only have the VIC, the routing, and the DHSVM, and that's what we want to test. Also inside CyberWater, we have access to the GrassGIS, which is already part of the installation process in the manual. But the GrassGIS enables us to do any type of operation that a GIS can do inside CyberWater. So this is another visualization tool that CyberWater offers, which is just snapshots of one time step. In this case, all the elevation and all these maps are just one map. It doesn't change in time. But this is just a few examples of the kind of information you can generate inside CyberWater and like prompt in without changing the interface of these trails. This is a typical process where we define the strip network of a basin. We just start with the elevation, and any other map is just generated by the computation of the elevation. Of course, we do need to know the outlet of the basin in order to be able to generate the basin, or this is the mask of the watershed. And and visualization tools. So there's 3 types of visualization. We already checked them all. So the first one is this one that I'm showing, which is snapshots of single time steps. The second type of visualization that CyberWater offers is this time series, these are average over the space that we are simulating. And the third type of visualization are the animations that we're showing here. So you guys can also see the variance in space and time at the same time using these animation tools. And I think that's it. So if anybody has questions about what we should show here, please raise your hand. We can answer any question.